We are tracking a weather system of truly historic, frankly terrifying dimensions this week down in the Caribbean.
Yeah, it's really shaping up to be a major event.
Our focus today is entirely on Hurricane Melissa. It's a storm that has just exploded in intensity over these incredibly warm waters.
Record waters, yeah.
And now it looks like it's aiming to become, potentially, the strongest storm ever recorded to hit Jamaica.
That's the forecast, and it's deeply concerning.
We're going beyond just the wind speed today. We want to look at how the physics, the geography of the islands, and, well, human vulnerability are all converging. It looks like a real worst-case scenario brewing.
It really does. The ingredients are all there.
Welcome to Meteorology Matters, the podcast that dives deep into the science, chaos, and stories behind the weather that shapes our world. This show was created by meteorologist Rob Jones, and we're doing something new this season, offering every episode in English and Spanish. Yeah, that's right, same stories, 2 languages. Why? Because weather impacts everyone, and science should speak to all of us. But here's where you come in. We want to know what you think. Is this bilingual setup awesome? Confusing, totally unnecessary? Tell us straight up on social media. Comment, like, share, or DM us, and let it rip. Now, let's get into today's episode of Meteorology Matters. Okay, so as of right now, Sunday, October 26th, 2025, the picture from the National Hurricane Center is, well, it's urgent. It's extremely dire. Hurricane Melissa is sitting there as this monster Category 4 storm. Winds are packing 140 miles per hour, sustained.
A very powerful Cat 4.
And its location is critical. It's about, 110 miles south of Kingston, Jamaica?
That's right. Close enough to be an imminent threat.
But the immediate danger isn't just that distance, is it? It's the speed, or lack thereof.
Yeah, exactly. That slow pace is arguably the single most devastating factor in this whole setup.
Right.
Melissa is moving at what the National Hurricane Center is calling a near snail's pace. We're talking 3 to 5 miles per hour, just crawling.
3 to 5 miles per hour.
Yeah, and when you have a storm this intense moving that slowly, think about the duration, the extreme wind just stays and stays, and maybe even more importantly, the rainfall.
Oh, the rainfall.
The volume of rain dumped over one single area gets multiplied exponentially. You're not just getting a quick hit, you're facing this hours-long sustained siege.
A siege. That's a good word for it.
Yeah.
And the forecast track is bringing this slow-moving monster right towards Jamaica.
Yeah, it's expected to keep drifting west very slowly for maybe a few more hours, just kind of sitting over that extremely warm water, probably gathering even more strength.
Building strength.
And then comes the pivot, the anticipated turn.
Okay, when do we expect that?
We expect that turn towards the north and northeast to really begin on Monday.
Okay.
And that track brings the catastrophic core of the storm. You know, the tight inner eye wall with the absolute strongest winds near or over Jamaica. That's the official wording. Late Monday into the early hours of Tuesday morning.
Late Monday, early Tuesday. And the big concern here is that it keeps intensifying during this slow crawl towards the island.
That's the key concern. Continued intensification.
So let's talk about that intensity prediction, because this is where Melissa really seems to be separating itself from history in Jamaica. It's already a beast at Cat 4.
A strong Cat 4, yes.
But the consensus among the highest-end weather models, the research we're seeing, is that strengthening isn't just expected. It's likely to reach the very top of the Saffir-Simpson scale.
Yes. The forecasts are now explicitly predicting Melissa will achieve catastrophic Category 5 intensity.
Did you hear that?
Either right before or potentially right as it makes its closest approach or landfall on Jamaica.
And if that happens...
If that happens, Melissa won't just rival the strongest storms in Jamaica's history. It will officially surpass all recorded historical storms to hit the island. It would be the strongest on record.
Strongest on record. We have to compare this, inevitably, to Hurricane Gilbert back in 1988. That's the benchmark, right? The storm everyone remembers for the devastation it caused.
Gilbert is definitely the historical benchmark, an intense, devastating storm. But structurally, Melissa looks like it could present an even more concentrated, maybe more severe threat in some ways.
How so?
Well, Gilbert's intensity was horrific, no question. But Melissa's sustained wind speeds are forecast to be significantly stronger. We're talking about potentially crossing that 157 mile per hour threshold for Cat 5.
Okay, stronger winds.
But maybe the bigger difference is the damage corridor. Gilbert essentially raked the whole island from east to west. It spread its worst impacts over a longer path.
Right, I remember that track.
Melissa, because it's forecast to turn north, is carving this narrower but incredibly intense path, sort of a south to north corridor.
Okay.
And that path looks set to directly impact major population centers, critical infrastructure, particularly along that south coast, with the absolute worst of the eye wall. It's like a focused perpendicular assault.
So instead of spreading the damage, it's concentrating the maximum energy on one area, including Kingston potentially.
Exactly. It delivers the maximum kinetic energy, the maximum force, to structures in that narrower zone.
The gravity of this, it's really reflected in the language coming out of the National Hurricane Center, isn't it? They're not mincing words.
No, they've abandoned the usual sort of measured meteorological tone. It's a clear, urgent message now. They're saying time has essentially run out for people to prepare.
Run out.
And they are telling every resident in the potential path to seek shelter now. Not tomorrow, not later today, now.
Seek shelter now. And the warnings about the consequences, what happens after the storm, are just as stark.
Equally stark. They're talking about extensive infrastructural damage. And that's not just homes. That's major roads, bridges, ports, the power grid, everything, which leads directly to long-duration power and communication outages. We could be talking weeks, maybe longer in the hardest-hit areas.
Weeks without power or communication.
And critically, this leads to prolonged isolation of communities. If roads are out, bridges are down, communication is gone.
Help can't get in.
Exactly. Rescue and relief efforts become incredibly difficult, maybe impossible, for days after the storm finally moves away.
And that prolonged isolation directly impacts the advice they're giving now, right? It's very specific about where to shelter.
Highly specific. People absolutely must find shelter in sturdy concrete buildings, not wood, not flimsy structures, concrete.
And crucially, above potential floodwaters.
Above any potential floodwaters, storm surge and freshwater flooding are both extreme threats here.
And the duration. They're saying people need to be prepared to stay put for a long time.
Yeah, that duration of stay is key. The advice is clear. People might need to remain sheltered, completely self-sufficient, for over 24 hours straight.
Over a full day.
Think about it. With Melissa moving at that 3 to 5 mile per hour pace, just the inner core, the eye wall, and the most intense surrounding bands could take 12, maybe 18 hours just to pass over a single point on the island.
Wow.
And that's not even counting the hours of tropical storm conditions before and after. So yeah, you absolutely need enough food, water, medication, everything for a full day, maybe longer, while the absolute worst is happening outside.
Okay, let's shift focus slightly to the water threats, because with a slow-moving, intense hurricane hitting mountainous islands like Jamaica, like Haiti, the rainfall is often the biggest killer, isn't it? Sometimes even more than the wind.
It absolutely is. The hydrological risk here is paramount. Melissa is forecast to bring volumes of water that are almost difficult to comprehend.
The numbers I saw were staggering.
They are. We're looking at widespread storm totals across the whole affected region of 15 to 30 inches of rain. That's forecast through Wednesday. 15 to 30 inches widespread.
That alone is massive.
But the real headline is the local maxima. The potential in certain spots, especially where the terrain enhances the rainfall. We are talking about the possibility of 40 inches or more of rain locally.
40 inches. Can you put that into context for us? What does 40 inches of rain actually look like?
Well, when you start getting numbers like 30 or 40 inches from a single storm system, you really have to stop thinking in inches. You're measuring rainfall in feet.
Feet of rain.
40 inches is 3 1/3 feet of water falling out of the sky onto the land, potentially over just 48 hours or so.
Unbelievable.
And that incredible volume is a direct result of two things. Melissa's slow forward speed, just sitting there raining, and the extremely efficient moisture-generating engine of a near Category 5 hurricane sucking up all that tropical moisture.
And there's another factor, isn't there? The ground conditions before Melissa even gets there.
That's a critical compounding factor. The ground across much of Jamaica and Hispaniola is already saturated from previous smaller weather systems that have moved through recently.
So it can't soak up any more water.
Exactly. That pre-existing saturation basically removes the soil's ability to absorb any significant new rainfall. It means nearly all of this torrential rain immediately becomes surface runoff. Overwhelming, immediate runoff.
And that overwhelming runoff hits the specific geology of Jamaica.
Which is highly vulnerable. Jamaica is mountainous, characterized by very steep slopes, high elevation changes, deep valleys.
A recipe for disaster with that much water.
It's extremely conducive to catastrophic flash flooding in the valleys and rivers
Yeah.
and numerous widespread, potentially massive landslides on those steep slopes.
Landslides.
We're looking at what meteorologists call a compounding event.
Hmm.
The torrential rain saturates the mountainsides, the immense weight of that water overcomes the soil's friction, and you get huge amounts of earth, rock, debris just letting go and sliding downhill.
And that doesn't just block roads.
No, it can wipe out entire homes, entire communities built on or below those slopes. It isolates regions for weeks, maybe months, if major roads are taken out. It's a huge, deadly threat.
Okay, so massive freshwater flooding and landslides from the rain. Then there's the other water threat, the storm surge from the ocean, specifically targeting the south coast.
Yes, a life-threatening storm surge hazard is expected along the south coast, likely peaking late Monday through Tuesday morning as the storm makes its closest approach.
And the forecast heights for that surge?
They are terrifying. Peak surge heights are projected to reach 9 to 13 feet above the normal high tide mark.
9 to 13 feet above normal high tide.
Correct. Concentrated near and, importantly, to the east of wherever the center makes its closest approach or landfall. Remember, the strongest winds pushing the water are typically on the right side, the east side, of a northbound storm in the northern hemisphere.
So if you factor in the normal high tide itself, what kind of water levels are coastal structures actually facing?
You could easily be looking at 15, maybe even close to 20 feet of rushing, destructive saltwater inundating the immediate coastline in the worst-hit areas. It's not just standing water, it's driven by hurricane-force winds.
We really need to highlight the specific vulnerability of Kingston, the capital, in this surge scenario. Its geography seems almost perfectly designed to maximize the damage from a storm coming from the south.
It's tragically positioned for this specific track. Kingston Harbor opens directly to the south.
Right into the oncoming surge.
Exactly. It's the precise direction the peak surge will be coming from as Melissa moves north. Experts have noted that the geometry of the harbor, the way it narrows, acts like a giant catcher's mitt. It catches the incoming surge, funnels it, and potentially enhances its height as it pushes into the densely populated coastal areas around the harbor.
And the absolute worst-case scenario for Kingston's surge
Is if Melissa makes landfall, or its closest approach, just slightly west of Kingston. That would put the capital in that right front quadrant, aligning the peak surge perfectly with the harbor's southward-facing entrance. That would be devastating.
This puts the Kingston International Airport in immediate, perhaps existential danger, doesn't it?
Absolutely. The airport, Norman Manley International, is located on a very narrow peninsula, technically a tombolo, called the Palisados, that juts out, basically enclosing the harbor.
Very low-lying, right?
Extremely low-lying. If that 13-foot surge materializes, coinciding with the peak winds battering that narrow strip of land, the forecast indicates the entire airport facility would be completely inundated, possibly destroyed.
And losing that airport.
Losing that major logistical hub would critically complicate any post-storm recovery efforts for the entire country. Getting aid in, getting people out, it becomes vastly harder.
Okay, looking beyond Jamaica now, Melissa's sheer size means this catastrophe isn't confined to one island. We have to talk about the expected impacts on Hispaniola, particularly Haiti and also Cuba.
Definitely. The situation shaping up in Haiti, especially on the southwestern Tiburon Peninsula, looks equally catastrophic, maybe even more so given the existing vulnerabilities.
That area has already been hit by storms recently, hasn't it? Leaving the ground unstable.
Yes, the soil is already saturated and unstable from previous heavy rains and storm activity. Now, Melissa is forecast to bring catastrophic flash flooding and landslides right through the middle of the week.
And the rainfall totals for Haiti.
Potentially even higher in spots than Jamaica. Forecasts call for total rainfall possibly reaching 3 feet of water in the mountains there. 3 feet.
3 feet of rain on those deforested, unstable hillsides.
It's unimaginable. And unlike Jamaica, Haiti's infrastructure is far more fragile. Housing is often less resilient. The potential for loss of life there is extremely high with this kind of sustained assault.
And tragically, that earlier storm activity you mentioned has already claimed lives in Haiti.
Yeah.
Even before Melissa's Corps arrives.
That's a crucial, heartbreaking point. We already have confirmed deaths reported from earlier storm impacts a landslide in the Fontamara area near Port-au-Prince, a falling tree in Marigot. Melissa's arrival will just compound this ongoing tragedy.
Isolating communities further.
Potentially isolating entire villages for weeks, especially where critical roads, which are often just dirt tracks, are inevitably going to be washed out or buried by landslides.
Further west, Cuba is also bracing for a significant impact. There's a hurricane watch up for the eastern provinces.
That's right. Granma, Santiago de Cuba, Guantanamo, Holguin provinces are all under a hurricane watch.
And what's the forecast for Cuba? Still a major hurricane.
The forecast suggests it will still likely be a major hurricane impact as it moves near or over eastern Cuba. Rainfall is expected to be in the 10 to 15-inch range generally, but local totals could hit 20 inches, especially in the mountainous Sierra Maestra region.
And again, mountains plus torrential rain equals.
Life-threatening flash flooding and landslides. It's the same deadly equation. It will particularly impact rural communities, agriculture in that part of Cuba.
And looking further out, as Melissa continues moving generally northwest after impacting the Greater Antilles,
The risk profile then increases significantly for the southeastern Bahamas and the Turks and Caicos Islands by the middle of the week. They need to be watching this very closely.
and even further down the line.
Bermuda will need to monitor the system later in the week as it potentially curves out into the Atlantic.
So the core takeaway from all these impacts, it's the sheer slow motion combined with this intense rainfall over mountainous islands. It's just a perfect recipe for a multinational disaster.
It really is. It echoes some of the worst historical storms in the Caribbean, like maybe Hurricane Flora back in 1963, which also stalled and caused horrific flooding and loss of life across Hispaniola and Cuba due to its slow movement. This is that kind of setup.
Okay, we've established the truly devastating potential impacts on people, on infrastructure, on the geography. But all that destruction is ultimately the result of this incredibly efficient, almost perfect natural engine. Let's shift focus now to the science, the thermodynamics, the physics that are driving this monster towards Category 5 strength.
Absolutely. Let's look under the hood.
Okay, first off, Melissa didn't just gradually strengthen. It went through what's called rapid intensification, or RI, extreme RI, actually.
It really did. It went from basically a low-end tropical storm to a high-end Category 4 hurricane in just 24 hours.
What's the official definition for RI?
The official threshold used by the National Hurricane Center is a 35-mile-per-hour increase in the maximum sustained wind speed over a 24-hour period.
Yeah, Melissa.
Melissa essentially doubled that rate. It jumped from roughly 70-mile-per-hour winds to 140-mile-per-hour in that same 24-hour window. That's explosive strengthening.
What allows that kind of explosion to happen? What are the ingredients?
For that level of RI,
Yeah.
you generally need a perfect storm, meteorologically speaking, of ingredients. 3 key things. 1, very deep, very warm ocean water, the fuel. 2, very low vertical wind shear, meaning the winds aren't tearing the storm apart at different altitudes. And 3, high moisture content through a deep layer of the atmosphere. Melissa found all 3.
Let's focus on that first ingredient, the fuel source, the warm water. That seems particularly critical here.
It absolutely is. The storm is currently sitting over, churning up, near record warm Caribbean water. Sea surface temperatures have been measured at a scorching 86 degrees Fahrenheit. That's bathwater temperature.
86 degrees. But it's not just the surface temp, is it? It's the depth of that warmth.
That is the crucial element here. The research flights and ocean buoy data show that this 86-degree water isn't just a thin layer on the surface. It extends down incredibly, about 200 feet deep.
200 feet of 86-degree water. Why is that depth so critical for allowing a storm to get this strong and stay this strong?
Okay, think about what a strong hurricane does. Its powerful winds churn the ocean surface violently. Normally, this process, which we call upwelling, mixes the water and brings cooler water up from deeper down.
And that cooler water acts like a brake, right? It cuts off the fuel supply.
Exactly. It typically limits how strong a storm can get or causes it to weaken. But because Melissa is churning over 200 feet of uniformly warm water,
There's no cool water to bring up.
precisely, the storm is completely protected from its own self-induced upwelling. It has this immense, practically inexhaustible reservoir of high-octane fuel beneath it that allows it to reach and potentially sustain peak intensity for a much longer period than it otherwise could.
Okay, so the water is the fuel. Let's talk about the engine itself, this whole concept of hurricanes being warm core systems. How does releasing heat in the middle actually power the storm to these extreme wind speeds?
Right. So think of the hurricane as this massive kind of inverted thermal engine. It's operating between the warm, moist ocean surface and the very cold upper atmosphere, maybe 40,000, 50,000 feet up.
Right.
Air spirals into the storm at the surface, picks up heat and moisture, then rises rapidly in these incredibly intense thunderstorms that form the eye wall.
And as that air rises,
As that warm, moist air rises and cools, the vast amount of water vapor within it condenses into cloud droplets and rain. This condensation process releases an enormous amount of energy, which we call latent heat, into the air surrounding it.
Latent heat release.
Yes. And this happens on a massive scale in the eye wall, creating this powerful, buoyant column of exceptionally warm air right in the center, in the core of the storm.
And this heat must be pretty extreme in a storm like Melissa.
It is. The data gathered by the Hurricane Hunter aircraft that flew into Melissa showed that the air inside the eye, at altitude, was measured to be about 16 degrees Fahrenheit warmer than the surrounding air outside the eye wall at the same level.
16 degrees warmer in the eye.
That massive temperature difference, that column of exceptional warmth, is a profound indicator of a deeply intense, highly efficient, well-organized hurricane. It's the signature of a storm that has basically maxed out its thermodynamic potential.
And it's this intense heating mechanism in the core that ultimately drives the extreme wind speeds we see at the surface. It creates like a vacuum.
That's precisely right. Those powerful updrafts in the eye wall, fueled by the latent heat release, lift air away from the surface incredibly rapidly. They literally remove air mass from the center faster than air can rush in at the bottom to replace it.
Creating a void.
Creating a void, or more accurately, a massive deficit in atmospheric pressure in the storm center at the surface. Air from the higher pressure areas outside the storm then rushes violently inward, trying to fill that low pressure void.
And that inward rush of air is the wind.
That is the hurricane force wind we measure. The stronger the heating, the more air is lifted out, the lower the central pressure drops, the steeper the pressure gradient between the center and the outside becomes, and the faster the wind blows trying to equalize it.
And the research provided a really stunning number for just how much air is missing from Melissa's center.
Yeah, the current analysis, based on the pressure readings, suggests that approximately 6 to 7% of the atmosphere's normal ambient mass is currently missing from the column of air in Melissa's center.
6 to 7% of the air is just gone.
Essentially removed by the storm's dynamics. It's a staggering amount. And the physics here are really nonlinear. As the pressure, measured in millibars, drops lower and lower,
The winds ramp up faster and faster.
the pressure gradient force driving the air inwards intensifies exponentially. So even a small further drop in the central pressure now could translate into a massive jump in wind speed. That's why we're seeing these Cat 5 predictions becoming so likely.
And where's the intensity headed now? You mentioned it's nonlinear. It doesn't just climb smoothly.
Correct. Hurricane intensification isn't usually a smooth upward curve. It often involves these internal dynamics, things like eye wall replacement cycles, where an outer eye wall forms and chokes off the inner one temporarily.
Okay.
That can cause the intensity to briefly plateau or even dip slightly before sometimes a sharp, abrupt reintensification occurs as the new, often larger eye wall consolidates.
So the forecast models have to grapple with that complexity.
They do. It makes pinpointing the exact peak intensity tricky. However, the high-end guidance, especially looking at some of the advanced ensemble models, maybe even some AI-driven predictions like from Google DeepMind research that's been emerging,
What are they showing?
they're consistently showing an over 80% probability now of Melissa reaching that critical Category 5 threshold, 157 mph or higher, before it impacts Jamaica.
Over 80% chance of Cat 5.
Which tells us that even if the storm fluctuates a bit, say between 150 mph Cat 4 and 160 mph Cat 5 right at the moment of peak impact, the results on the ground are going to be catastrophic regardless.
The impacts are effectively Category 5 impacts, whether it's technically 150 mile Cat 4 or 160 mile Cat 5 at landfall.
Absolutely. For the people experiencing this, the difference between a really high-end Category 4 and a Category 5 is frankly academic. It's splitting hairs. What matters is the prolonged duration of those extreme winds, the astronomical rainfall, the massive surge.
Yeah.
The practical difference between 140 mph winds and 160 mph winds is mostly measured in just how much more debris, like plywood, sheet metal, signs, becomes airborne and turns into potentially lethal projectiles. The level of devastation is already locked in as extreme.
Okay, this is where it gets, well, really visceral. For the people who are currently hunkered down in Jamaica waiting for this, they're about to experience, or maybe are already starting to experience, this terrifying sequential assault on their senses. Let's try to walk through that sensory journey. What is it actually like to be inside the core of a storm this powerful?
Yeah, let's try and paint that picture, because preparation involves anticipating this sensory onslaught. Long before the hurricane winds actually arrive, maybe a day or two out, the first visual clue that something immense is out there is often the sky itself.
You mean those really vivid sunrises and sunsets?
Exactly. You get these extra orange, deep pink, almost artificial-looking sunrises and sunsets that's caused by the hurricane's outflow, its upper-level exhaust system, basically spreading these thin, icy cirrus clouds very high up, maybe 35,000, 40,000 feet.
And they catch the light.
They catch the low-angle sunlight perfectly at dawn and dusk. It's often eerily beautiful, but it's the calling card of a very large, very powerful system churning away offshore.
Okay, then as the storm gets closer, maybe within 12, 24 hours,
You feel the air change first. It becomes oppressively muggy, humid. Then the outer rain bands start to arrive. These are often intermittent. At first, you get a short, sharp downpour, maybe some gusty winds, then a brief lull, then another band comes through.
and the wind starts picking up gradually.
Right. It begins maybe with just a casual swaying of the palm trees, say 15, 20 mile per hour. The initial raindrops in these outer bands are often quite large, fat, distinct drops.
But then the squalls become more constant.
Yeah, as you get closer to the core, the squalls become more frequent, then eventually merge into just constant rain and wind. Once the wind hits sustained speeds of around 40 mile per hour official tropical storm conditions, the whole soundscape changes.
How so?
You start hearing that frantic, noisy rustling and whipping sound of palm fronds. You start hearing the first sounds of light debris, small branches, leaves, maybe loose items starting to blow around and hit things.
And the rain changes too.
Pay attention to the water, yeah. The research notes this distinct transition. As the winds intensify, the raindrops stop being big and fat. They become much smaller, littler, but far more numerous, almost like a spray,
Driven by the wind.
driven hard by the intense wind field. At this point, maybe in the 60, 70 mile per hour range, you're experiencing rainfall rates that can easily exceed 3 inches per hour. Puddles are no longer puddles. They rapidly merge into sheet flooding because the ground just can't absorb it anymore.
And you cross that threshold, 74, 75 mile per hour, into true hurricane force. What happens then?
Okay, now you're in it. The power is likely out by now, or will be soon. The rain is no longer really falling downwards. It's being driven almost perfectly horizontally. It becomes this constant spray of tiny droplets. People describe it like being blasted continuously by a fire hose, but one set to a fine, stinging mist.
Horizontal stinging mist.
And because of that, freshwater intrusion becomes a major problem inside structures, even well-built ones. The wind pressure difference between outside and inside becomes so immense.
it pushes water through tiny cracks.
It physically blows water through any tiny crack or crevice it can find. Under doors, around window frames, through vents, even through seemingly solid walls if there are any imperfections. People often find their homes are getting wet, even flooding slightly from the sides and top, not just from water rising from the ground.
And the sound.
Yeah.
What does hurricane force sound like?
The sound becomes overwhelming. It's not just wind noise anymore. It's described as a constant, deep, chaotic roar.
Roar.
Yeah, many people who've been through it compare it precisely to the sound of standing next to a massive, continuous waterfall or maybe a freight train that never passes. It's just this all-encompassing, deafening roar right outside your windows, sometimes for hours on end.
What causes that specific roaring sound?
It's believed to be caused by millions upon millions of miniature vortices, tiny, intense whirls of air constantly forming and shedding as the main wind flow curls around every single physical obstacle it encounters. Corners of buildings, trees, power poles, fences. Each tiny vortex contributes to this overall acoustic energy, this pressure trauma on your ears.
And you start to hear the building itself reacting.
Oh, yeah. Inside, especially in a wood frame house, but even in concrete structures, you will start to hear your house creaking, groaning, maybe popping sounds. That's the sound of the immense, sustained stress the wind is putting on the structure, trying to lift the roof, trying to push in the walls, flexing the frame. It's unsettling.
And speaking of unsettling internal effects, let's go back to that incredible detail from the research, the toilet bowl phenomena. That image is so bizarrely specific. Seeing the water in your toilet bowl sloshing violently back and forth, like you're on a ship in rough seas.
Isn't that amazing? It is a truly stunning, real-world physical manifestation of the storm's invisible power acting directly on your house's systems.
How does that work scientifically?
Okay, to understand it, you have to remember your house's plumbing system, the drains from your sinks, showers, toilets. They're all connected to a septic tank or the main sewer line. But critically, that system also has a vent pipe.
Right, usually sticking up through the roof.
Usually a pipe sticking out of the roof. That vent pipe's job is to allow air pressure inside your plumbing system to equalize with the outside atmospheric pressure, preventing suction issues.
Okay.
Now, imagine hurricane-force winds, maybe gusting over 100, 120 mile per hour, screaming across the top of that open vent pipe on your roof. Those gusts cause rapid, extreme fluctuations in the air pressure right at the mouth of that pipe.
So the pressure outside the pipe is going crazy.
Exactly. And that rapid pressure difference compared to the relatively stable air pressure trapped inside your sealed plumbing pipes below, that differential is strong enough to physically push and pull on the column of air inside the pipes.
And that moves the water.
That push-pull literally forces the fluids within the pipes, including the water sitting peacefully in your toilet bowl trap, to shift violently back and forth until the pressures momentarily stabilize again between gusts. It's a direct visualization of the atmospheric pressure deficit we talked about earlier, playing out in your bathroom.
That is a terrifyingly brilliant illustration of the forces at play. Okay, so the wind is roaring, the house is groaning, the toilet is sloshing. As the pressure continues to drop, we approach the most dangerous part, the inner eye wall. But there might be a strange lull just before it hits.
Yes, sometimes right on the immediate outskirts of the most intense eye wall core, there can be a narrow band of briefly sinking air. Meteorologists sometimes call this the moat region.
And the sinking air causes the wind to decrease.
For a short period, yes. The wind speed might decrease quite noticeably, maybe drop back down to strong tropical storm force for a few minutes. The rain might lessen. It can feel like a deceptive reprieve.
Deceptive is the key word.
Absolutely. The research, the warnings, they all emphasize this is not a chance to relax or go outside and look around. This is the absolute final moment you have to get into the safest possible place in your shelter, the most interior room, away from windows, on the lowest floor, not subject to flooding, before the absolute peak fury of the storm hits.
And when that eye wall hits,
Yeah.
it's sudden. It's total.
It's often described as hitting like a wall, instantaneous, total fury. You go from maybe 60 mile per hour winds in the moat to gusts well over 110, 130, maybe 150 mile per hour or more within minutes.
Wow.
It's a complete whiteout event. Visibility drops to practically zero, maybe less than 30 feet, sometimes just a few feet. The rain becomes an opaque, horizontal sheet, driven with such force it feels solid.
And this is where the major structural damage happens.
This is it. This is where you hear shingles and siding peeling off like paper. This is where windows, even boarded ones, might fail under the pressure and impacts. This is where roofs can begin to lift off. This is the stage where the wind easily turns unsecured objects, even fairly large ones, into deadly projectiles.
There's another sense involved here too, right? The sense of smell.
Yes, interestingly. Researchers and survivors often note a distinct, unique scent during the peak of the eye wall passage. It's often described as the smell of freshly cut grass, or maybe like being inside a giant greenhouse.
A greenhouse smell. What causes that?
It's believed to be the smell of freshly defoliated vegetation. The incredible violence of the wind is literally shredding every leaf, every needle, every bit of green off the trees and plants in its path. This massive shredding releases volatile organic compounds from the damaged plant matter into the air, creating that strange, slightly sweet green scent amidst the chaos.
Wow. And sometimes, rarely, you might even get lightning in the eye wall.
It's exceedingly rare in a mature, well-developed hurricane eye wall because the air motion is predominantly horizontal, which isn't great for the charge separation needed for lightning.
But if it happens,
If you do see flashes of lightning or hear an occasional crash of thunder embedded within the eye wall's roar, that is considered a profound signal. It usually indicates that the updrafts within that section of the eye wall have become so violently powerful, so turbulent, that they are managing to generate significant charge separation. It often points to an exceptionally intense storm core, or possibly one that is still rapidly strengthening. But honestly, you'd be lucky to even hear thunder over the sheer scream of the wind at that point.
okay, so the eye wall rages. As the storm continues its slow crawl, the winds might become even more erratic on the inner edge due to smaller vortices.
Yes, embedded within the main eye wall circulation, you can get these smaller, very intense whirlwinds called mesovortices. They might only be a few miles across, but they contain extreme winds and rotate around within the main eye. As these sweep past, they can cause sudden, violent, and direction-changing gusts that are even stronger than the background wind field.
And then, after potentially hours of this eye wall fury, suddenly, it stops.
Abruptly. If you are directly in the path of the eye itself, the wind can drop from over 100 miles per hour to almost calm, maybe just 10, 20 miles per hour in a matter of minutes. The deafening roar ceases, replaced by an eerie, almost unnatural quiet.
You've reached the eye.
You're in the eye of the hurricane. It's often described as a very odd place. The physics flips. Instead of violently rising air, the air in the center is gently sinking. As it sinks, it compresses and warms.
So the sky clears.
Often, yes. The skies brighten significantly. You might see patches of blue sky, maybe even glimpse the sun directly overhead if it's daytime, even while the ground level might remain misty or hazy with spray.
And the soundscape changes completely again.
Totally. That massive roar is gone. Instead, you hear this incredibly ill-timed, unsettling chorus emerge from the wreckage.
What kind of chorus?
Tree frogs, crickets, insects. They all suddenly start chirping and singing loudly, utterly disoriented, probably thinking the storm has passed because the wind and rain stopped. It's bizarrely noisy in a completely different way.
And you might see birds.
Yes, look up. You may well see exhausted, completely disoriented birds flying around inside the eye. They get swept into the storm, can't fight the winds to get out, and essentially become trapped, forced to fly along within the calm center. They often fly until they reach land or just collapse from exhaustion.
And the most dramatic sight, if you're lucky or unlucky enough to see it, the stadium effect.
Ah, the stadium effect. That is the truly profound, perhaps once-in-a-lifetime moment you might experience in a strong hurricane's eye. If the clearing is wide enough and the eye wall structure is sharp enough,
You can see the wall of clouds surrounding you.
you can literally look up and see the towering, nearly vertical wall of the surrounding eye wall clouds completely encircling the calm area you're standing in. It looks like you are standing on the field at the bottom of a giant, churning stadium made of cloud. It's described as a moment of terrifying, awesome, terrible beauty.
But a moment that comes with a critical warning.
An absolutely critical warning. The research, the survivor accounts, they all say, the moment you might witness that stadium effect or any clearing in the eye is not the time for sightseeing. You need to assume the worst danger is still ahead and get immediately back into your safest shelter.
Why is the eye itself still so dangerous, even if the wind is calm where you are?
The danger is twofold, really. First, remember those mesovortices we mentioned? Those smaller whirlwinds? They don't just stay in the eye wall. They can and do pivot right through the eye itself without warning.
So you could get hit by a sudden 80-mile-per-hour gust out of nowhere.
Easily. Gusts of 80 miles per hour or even higher, changing direction rapidly, can sweep across parts of the eye unexpectedly. If you're complacent and step outside to assess damage, you could be caught completely off guard and seriously injured, or worse, by flying debris kicked up by one of these vortices.
Okay, that's one danger. What's the second?
The second, and perhaps even more critical danger, is the arrival of the backside of the eye wall. When the eye passes and the winds return, they will be blowing with just as much fury as the front side, but from the exact opposite direction.
I mean, from the other way.
Exactly. And any structure, any tree, any power line that was already damaged, weakened, perhaps leaning from the initial hours-long assault from one direction, is now going to be hit by that same incredible force, but pushing it back the other way.
And that often causes total failure.
That reverse pressure and force is very often what causes structures that somehow survive the first half of the storm to fail completely during the second half. So the eye offers a brief, deceptive pause, but the danger is far from over. In fact, some of the worst damage occurs when the back eye wall hits. Stepping back and looking at the whole picture. The magnitude of the challenge facing Jamaica and Haiti and Cuba right now is just immense. We've really analyzed a true worst-case convergence of factors here.
Yeah, it seems like everything lined up in the worst possible way.
You have that incredibly slow forward speed. You have it sitting over that unprecedented depth of extremely warm water, providing almost limitless fuel. And then you have that fuel colliding directly with highly vulnerable, steep, mountainous terrain.
The terrain interaction is key.
It's absolutely key. When a storm possessing Melissa's kind of thermodynamic efficiency, its ability to process moisture, slows down or stalls over steep geography, the result isn't just measured in miles per hour of wind, it's measured in feet of rain. And that translates directly, inevitably, into catastrophic, life-altering landslides and infrastructure failure. It truly is the perfect meteorological storm for disaster in that region.
So let's recap the key points for everyone. We've covered the immediate historic threat, Hurricane Melissa, currently south of Kingston, intensifying towards a possible Category 5. That would make it the strongest storm ever projected to hit Jamaica.
A dire forecast.
It's bringing life-threatening storm surge, potentially 9 to 13 feet above high tide, especially dangerous for Kingston Harbor. We detailed the unique, almost scary physics driving this intensity, fueled by that 86-degree water extending 200 feet deep, creating that powerful warm core chimney effect and the massive pressure drop.
The engine is running at full throttle.
And we walked through that terrifying multi-sensory experience of what it's actually like to be inside the eye wall, from the house groaning, the waterfall roar, the strange smells, to that bizarre but telling toilet bowl phenomenon.
A visceral experience, no doubt.
It is absolutely vital for everyone in the path of Melissa, or potentially in its path, to monitor the official advisories. Those are issued by the National Oceanic and Atmospheric Administration, or NOAA, specifically the National Hurricane Center. Don't rely on rumors. Get the official word.
Critical advice. Official sources only.
And we also encourage you, if you want ongoing updates and analysis, to follow the creator of this show, meteorologist Rob Jones. He's very active on social media.
Where can people find him?
You can find him on Instagram. His handle is Meteorologist.
Yeah.
On TikTok, he's TV Meteorologist. And on YouTube, just follow Rob Jones Hurricane. And on that YouTube channel, you can also find the playlist for this very show, Meteorology Matters. And of course, please do like, follow, comment, and rate the show wherever you listen. It really helps us out.
You know, this whole deep dive into Melissa's physics, particularly that incredibly deep warm water layer, it really raises a crucial, maybe unsettling question for the future, something for all of us to think about long after Melissa passes.
What's that?
If we are now seeing these oceanic heat reservoirs, this deep warm water extending down 200 feet or more, becoming more common, maybe even the norm, in places like the Caribbean Sea or the Gulf of Mexico due to climate change, are we fundamentally entering a new era?
An era where Category 5 potential is baseline.
Exactly. An era where maybe Category 5 intensity is no longer the rare anomaly, but becomes the expected potential outcome for any reasonably well-organized storm that encounters this kind of high-octane oceanic environment. That kind of shift would have truly terrifying implications for coastal communities, for building codes, for regional preparedness across the board. It's something we need to grapple with.
You've been listening to Meteorology Matters, created by meteorologist Rob Jones. Now that you've heard both our English and Spanish versions, we really want your feedback. Is this bilingual approach helping more people connect with the science, or just making things messy? Don't stay quiet, jump on our socials and let us know what you think. Like it, share it, drop a comment, or send us a message directly. Your reactions, good, bad, or brutal, will shape how we move forward. Thanks for listening, and remember, the weather always matters, but so does your opinion.